Generative AI has moved through the enterprise at a scale that traditional software adoption cycles were never designed to handle. This data highlights a severe expectation gap. While 75% of executives view AI as a strategic priority, only about 25% report extracting significant, measurable value from their current implementations. This stall leaves the majority of firms in pilot purgatory. Roughly two-thirds of organizations are stuck testing models in isolated pockets, unable to scale these tools into production environments. The cause of this friction is a classification error. Many leadership teams are treating AI as a standard IT line item, a tool to do old work faster, rather than observing how it changes the cost of doing that work at all. Escaping this cycle requires moving past simple optimization. To scale, leadership must understand the new underlying economics of digital labor. Historically, enterprise output scaled with human headcount. But generative AI causes the marginal cost of cognition and computation to drop toward near zero. When automated upgrades save thousands of developer years, the firm's primary bottleneck moves from raw human resources toward imagination and execution. This collapse in costs activates three specific forces that rewrite how a business functions. The first force is abundance. Removing resource scarcity accelerates product reinvention. The second is flow. Natural language interfaces dissolve silos, turning static data into a fluid, shared resource. The third is autonomy. AI evolves into an independent problem solver, executing workflows without constant human direction. Mastering these three forces allows an enterprise to move through the three structural horizons of AI integration. This graphic maps the architectural roadmap to transition an enterprise from ad hoc pilots to an AI-native core. Horizon 1 is about efficiency through experimentation. Here, AI acts as an intelligent overlay on existing legacy systems, providing a soft landing. Progressing through this horizon requires a non-negotiable 90-day sprint methodology to prevent pilots from stalling in the testing phase. In days 1 through 30, the focus is foundational IT readiness. This involves building data ingest pipelines, like retrieval-augmented generation, to connect internal datasets to a secure model. Days 1 through 60 move into rapid piloting. Teams execute agile sprints, tracking ROI while steering committees manage the risks of model hallucinations. In the final 30 days, successful pilots are embedded into daily workflows. Models are containerized and wrapped in APIs, transitioning them from experiments into operational tools. The danger here is the efficiency illusion, the belief that incremental time savings on routine tasks equate to structural change. Horizon 1 is about building operational muscle. Capturing true value requires breaking down silos and moving into Horizon 2. In Horizon 2, the objective shifts from speed to quality. The goal is to improve the precision of enterprise processes and decisions at scale. Here, the force of flow becomes visible. Rigid software pathways dissolve, replaced by adaptive workflows that reconfigure based on natural language intent. Supporting this requires a dramatic infrastructure upgrade. Organizations move away from batch processing in favor of event streaming and mission-critical ML ops. However, this seamless operation creates a new tension, invisible complexity.
As natural language interfaces make tools simpler for the end user, the underlying system architecture becomes vastly more opaque and difficult to monitor. This creates a severe governance challenge. Tracing decision paths and maintaining accountability becomes highly difficult when systems are constantly rerouting their own operations. Navigating Horizon 2 requires moving past modular, siloed execution toward a unified, learning-first architecture. This leads to Horizon 3, transformation through reinvention. This stage allows the firm to execute operations that were previously impossible. The destination is the cognitive digital core. It integrates event streaming and ML ops into a unified system, using historical memory to coordinate decisions. Here, autonomy is fully realized. AI agents function as independent services within a composable mesh, negotiating and optimizing workflows without manual intervention. This forces an extreme shift in human utility. The human role moves away from task execution and toward oversight and strategic evaluation. This introduces the critical organizational dilemma of Horizon 3, the loss of direct execution control. In a multi-agent ecosystem, there is a risk that independent agents might optimize for local goals that conflict with the broader enterprise strategy. Traditional hierarchical management and standard compliance mechanisms are incapable of governing systems operating at this speed and level of autonomy. To prepare, leaders must adopt a future-back approach, envisioning this autonomous core from day one to ensure they are building for transformation, not just past optimization. The technical complexity of a cognitive digital core reveals a structural crisis. Success depends on the willingness to redesign the organization itself. Running this architecture requires a structural shift, moving from focusing on the technical infrastructure to empowering the human capital managing it. Historically, executive authority was rooted in information scarcity. Leaders simply knew more and held more experience than their teams. But when AI makes analysis and strategic insights instantly available to everyone, authority based on knowledge becomes obsolete. The new currency of leadership is judgment. Your team no longer needs you to provide the answers. They need you to decide which answers matter. This requires a specific skill, framing. Leaders must now specialize in defining the exact problem and setting the boundary conditions for autonomous systems. The executive's job is no longer to compete with the intelligence of the machine. Their job is to elevate their team's confidence in using it. This creates an operational paradox. Two companies can deploy the same technology and yield vastly different economic outcomes. In an environment built on fear, employees optimize for safety. AI is weaponized as a surveillance tool to monitor efficiency, and experimentation stops. In an environment built on trust, psychological safety allows for rapid experimentation, turning AI into an engine for creativity. Technology creates possibility. AI can generate options and execute tasks, but it cannot define meaning or purpose. The critical question for leaders is whether their people feel safe enough to think differently now that they have infinite cognitive resources. The success of the AI transition relies on a factor software cannot provide: a culture where employees feel secure enough to do their best thinking.